So, how do I sum up the privilege that has been to do this fellowship in just 15 minutes? I can't express it all. But what I hope to give you all tonight is an impression of what I've learned and where I hope we go as a profession. So, I started this journey thinking that I had a solid grasp on what sustainable design looked like. But the reality that we are facing is the Anthropocene, a geologic scale mass extinction event driven by the unfortunate combination of habitat loss and climate change. This isn't going to be rectified by a clever rain garden or a green roof. What is our professional impact on climate change? Ever since I started doing construction administration about 12 years ago, I always had a little bit of an uncomfortable feeling with this. What are the emissions that are associated with our projects? As far as we can tell now, about over 50% of the annual global emissions are coming from the built environment. That's including everything in the built environment, construction and operations of buildings, sites, infrastructure. This is our realm. We are culpable as an industry. We cannot have sustainable design if we don't first address the carbon impacts of our projects. We have to think about what we're building and not just the operational efficiency of what we're building. Architecture 2030 estimates about 50% of the total emissions in the life cycle of a building and about 90% for the life cycle of a site come from the embodied energy to build that facility. That's the carbon that it takes to make the materials, to transport them to site, to fabricate the facility, and the rest of it comes from operations. So if we're only addressing net zero operational facilities, we're missing a really big part of the picture. At the same time, as landscape architects, we have the unique privilege in the design industry of designing living systems. And right now, only in living systems do we have economically viable ways to contribute to carbon drawdown. So there should be a solution here. I was inspired by the work of LAF Fellow Pamela Conrad, who I can't see anybody, it's totally black out there. She's out there, she might be waving. She founded Climate Positive Design and issued a challenge to the industry. I wanted to build on that work and think about how we can start informing the earliest design phases in terms of our carbon impacts. Maybe before there's a project, maybe before there's an RFP, maybe for planners and urban designers to think about how they can move the needle, how they can set goals for carbon. At the earliest design phases, that's when the decisions are most plastic, and also when we can most effectively set and challenge client expectations. This research had to be inclusive of architecture and landscape together, civil engineering and infrastructure. With this kind of information, bringing it together, we can be more effective advocates for the investments in the landscape as carbon sinks. This can support the much needed restoration ecology work and reforestation work that will be critical parts of the future of carbon drawdown. The key unifying mechanism I chose was land use, as land use is the first and most fundamental unit of decision-making in urban design and planning, and ultimately dictates the building massing, space for habitat preservation, and landscape program frameworks. So, as you can probably guess, this got complicated. Trying to address the entire built environment. It became maybe paralyzing at times. The more I dug into the research on materials, buildings, and ecology, the more rigor that I added to my carbon accounting, the more externalities I tried to address, the farther out of reach it seemed to be to achieve low or carbon neutral design. I also realized that my preconceptions of sustainable landscapes created a confirmation bias in the work that I was doing. I needed to dig deeper. I needed to reach out to a community of experts. I talked to academics and sustainability design professionals. I got insight and peer review of my data sets. I sought advice in standards and conventions and LCAs and EPDs and many other acronyms that I'm happy to talk with you about in a much longer session. I collected a reference library of over 330 primary and secondary sources, now all of which I've tied together in a common carbon accounting model. I basically spent a large portion of this fellowship getting educated. I have learned along the way that there are global warming contributing emissions associated with every action we take, every material we specify, and everything that we build. As design professionals who make plans that can take decades to come into fruition, we must be aware of the climate implications of the decisions and recommendations that we are making right now. I have learned that landscape architecture can be just as emissions heavy as architecture on a per unit area basis. When we try to account for all aspects of site work, from demolitions to infrastructure, finish hardscapes, data, furnishings, lighting, fountains, playgrounds, everything, landscape can be a system of construction that is just as rich and complex as architecture, and just as carbon intensive. So by our LAF second residency, this awareness was becoming overwhelming for me. I love to build things. I love to design spaces. I love to design places. Is the only climate responsible project not doing the project? So let me step back. I left conservation biology in my early 20s as the career track I was considering for various PhD programs all sounded like documenting the end of the world. I was very depressed and sad. I fell in love with design because of its inherent optimism. You feel like you have the ability to take meaningful action. I've had the chance to work on tiny, sensitive green infrastructure projects, large-scale public parks, and super-programmed urban spaces all around the world. It has been a privilege to contribute to these places, and now my research is making me second-guess the value of what we provide as a profession. Is it worth the climate cost? This existential question spurred me to dive deeper into alternative materials and to learn what low-carbon strategies are out there that can be used and promoted. How can we do better? And tonight, I can say that I'm on the other side of that research and process, at least for now. It was cathartic, it was intense, and I can now say inspiring. The biggest conclusion I want to share with you all is that decarbonizing design is going to be very, very hard. But we must do so, and we can. This is not political. This is basic professional responsibility, just like health, safety, and welfare. How is our work impacting the future for our children? Those are my kids. They're amazing. I now believe that landscape architects have direct agency and power in decision-making that can reasonably meet our ASLA Climate Action Plan goals of 50% emissions reductions by 2030. I didn't always believe that in the past year. The problem is that we're used to building high carbon landscapes, and generally speaking as an industry, we don't know the alternative. My goal with this research has changed since I started this fellowship. It's now to make it easier for designers and planners to make carbon-conscious design decisions, so we can weigh the global warming impacts of our projects equally with the programmatic, monetary, cultural, and aesthetic priorities that we're used to thinking about. So I had started this fellowship having built a very poor draft version of this tool based on a very simple data set. But I had the opportunity in this fellowship to beta test this tool with Pamela, with my firm, with SWA Group, Atelier 10, public sector users, friends and family, basically anybody I could convince. And I wanted them to tell me what kind of feedback they had, what can be better. I learned I had two groups of users. The first user wanted to go in and noodle around. I like calling them the noodlers. They wanted to sketch with the tools, they wanted to play with the land uses, and then they wanted me to tell them what to spec. The second group wanted more functionality. They wanted me to justify exactly how this thing worked and how they can make it better. They wanted clear, more transparent sequestration models and database organization. They wanted more material options. They wanted to use the tool actively to figure out how to do better on their work. In parallel, I had the unique opportunity to be applying the lessons I was learning as fast as I was learning them on a large-scale project. This research became a driving factor in our design work in Athens, where it helped our team convince the client to reconsider their initial park program ratios and to commit to a large-scale program of material reuse, including upcycling, downcycling, and salvaging over 150,000 cubic meters of hardscape demolitions on site. The early goal phasing helped us have the social capital of the client, because they trusted at least that we were using some kind of data to inform our recommendations. They agreed to a host of carbon reduction and sequestration strategies, from product selection to soil amendments to successional planting strategies. This project work fed back directly into my research with LAF. It opened new avenues of inquiry practically into every spec section that we had in the project. Initially, I kept thinking that my lack of awareness of these practices as I was discovering them was my own lack of education, my own myopia. But I learned from feedback in our ASLA deep dive session in November on carbon, where we went through carbon at each project phase, that many of these practices are just not generally known in our profession, even if the research is well established in sister disciplines. I came away from ASLA realizing that we, as a profession, don't know enough to have an intuitive understanding of the carbon impacts of our work. And the scary thing is the relationship between the potentially large carbon impacts of best practices and the urgency to apply these lessons in practice. So for example, I'm only going to give a couple examples. In my early morning literature review time, I would read about how Sassobet wax additives to asphalt can reduce asphalt emissions by up to 20%, and it works through lowering the working temperature requirements required for HMA. That's very interesting. Later that day, I would call a contractor and discuss feasibility and local availability, and then I would revise my project specs that night. And in one move, I'd reduce the carbon factor for all the asphalt in the project by 20%, accounting for potentially tons of emissions with no performance issues. I just didn't know about it. Another example is that I would receive critique from an academic on my sequestration model for being overly conservative and that I hadn't considered all aspects of the carbon cycle. So I would dig a little bit deeper, such as accounting for allochthonic carbon, meaning the carbon that moves within an ecosystem, and incidentally, a word that I think only H.P. Lovecraft could appreciate. Later this year, I'm taking these studies and a lot of questions to the Society of Ecological Restoration and the Ecological Society of America for both of their annual conferences, as I believe we fundamentally need to be more integrated of ecologists as a profession to understand what we're doing in the built environment. So suffice to say, this research has fundamentally changed how I design as a landscape architect, from the large-scale work to how I muck about in my garden at home. And now I need to get these lessons out to our community. The first step will be the release of Carbon Conscious version 2, which will go live June 30th. This tool will be provided for free by Suzaki in perpetuity as part of a Creative Commons license. The revamped user experience is going to make it easier for my noodler friends to come in and sketch and start exploring the carbon impacts of land use by drawing, or the professional designers to be able to upload image files and spreadsheets so they can skip drawing in the tool. Apparently designers didn't want to have to do that. They didn't want to redraw their plans in our tool. A lot of feedback on that. These inputs provided the area takeoffs for land use in the app. These area takeoffs could then be mapped with different land use typologies that we've defined for landscape and architecture. You get a sum, and then you have a projection for the carbon impacts of your project. So in short, this is a whole project lifecycle assessment generator that accounts for material procurement, transportation to site, assembly, replacement costs over 60 years, and 60 years of sequestration and storage. I exclude operations because there's actually good tools for operations and energy modeling at this phase. We've gamified the user experience to enable more pathways for emissions reductions, including the ability to use a new suite of materials assumptions reductions, inclusive of supplementary cementitious materials, recycled content decisions, and material reuse. We've added this functionality to enable designers to make early phase design guidelines to help clients understand what the expectations materiality can be when they move into more detailed design phases. We've added a new suite of land uses, including civil infrastructure typologies, green roofs, street trees, and even alternative materials such as rammed earth. A key function has been adding land use splitting. So now if there's not a land use that exactly matches what designers want to use, they can make one by approximating from a couple of different land uses. These can also now add up to over 100%. So you can add another layer in, let's say, of saying adding in demolition underneath your finished design or a green roof on top of a building. In this release, we've also provided the data set, or I've provided the data set, with a full list of all citations so people can backtrack for the deep divers and know exactly where these numbers are coming from. I've also provided a Zotero library for academics, so anybody who wants to build on this work can download the full Zotero library, which has been mapped with metadata and notes, so people can search it and find the content easier. In addition, I've written a white paper that goes through a much more, let's say, robust background and methodology for the tool, and recommendations for how to do low-carbon design. If you want to read the white paper in advance of June 30th, you can access it through this QR code or just email me. I'm in the process of writing carbon-conscious design guidelines organized around principle or spec section for best practices that have been uncovered in the process that are maybe more tailored towards later design phases and maybe not necessarily relevant in the tool and application itself. Over the past year, I've had a lot of fascinating conversations with people across the industry and pan industries. And now I'm starting to go back and formally interview some of them and adding those discussions so that our community can benefit from these conversations. So after this release, the next steps of the work must include industry alignment. I'm in discussions with Pamela and others on how to define a common third-party baseline materials dataset, starting with this work. With a common baselines, we as an industry can develop workflows that are consistent year to year between applications and phases, encourage more work and innovation in this space. I'm happy to say that tonight we have the past, present, and future of this work supported by LAF, from climate positive design of Pamela, this year of carbon conscience, and moving forward of Meg Calkin's work in the next cohort for working on decarbonizing detailing. So let me leave you with this thought. The construction industry as we know it is a product of the Industrial Revolution. It's only 6 generations old. We had already been building low carbon landscapes for thousands of years. Change is not only possible, but it's the natural order of culture. We are gathered in the information revolution. We need to change how the construction industry works in 1 generation. We have the computing tools and the science to do so, but we need to be genuine and critical of our work. We need to make the right partnerships. We need to work together. We need to more effectively educate ourselves and our regulators, and we need to mobilize a generational effort. I believe that the future of low carbon design is going to be in natural, local materials. It's in restoration ecology. It's in defining a new relationship between the economics of cities and urban spaces and rural spaces. It's in a celebration of the vernacular, and it will require developing innovative operation strategies. This isn't just carbon accounting. These are all exciting design opportunities, and I look forward to exploring them with all of you as we continue to work together towards the preservation, improvement, and enhancement of the environment. Thank you very much.